Wesley, calling Wesley. The Weather Bureau of Investigation is calling Wesley. Are you there, Wesley?
This is Wesley, sir.
Are you ready for another day of training?
Yes, sir.
You're doing well, Wesley. Soon you'll be a real agent like all of us at the WBI, not just an agent in training.
What is my assignment today, sir?
Why weather changes. Wesley, come in, please, Wesley.
I'm in, sir. I'm out, but here I am.
Well, what have you observed about weather changes so far?
Well, sir, the weather hasn't changed since I've been observing it. It's a nice spring day here. It's been warm and pleasant like this for several days. The sky's sort of hazy blue.
Well, you're in a warm air mass.
A warm air what, sir?
A mass, Wesley. I'll explain. Look at your weather watch. You know that our planet Earth is surrounded by an atmosphere, air, that is constantly moving. But large masses of air can stay over a region for a long period of time. When they do, they take on the characteristics of that region.
I don't quite follow that, sir.
Well, for example, air that is over the ocean in a tropical region becomes very warm and moist, and we call it a tropical air mass. And air that stays over the polar regions for a long time
Gets very cold and has less moisture than air from a tropical ocean.
and it's called?
A polar air mass?
Very good, Wesley. And what's also important to know about air masses is that they move.
They move?
Yes, look at your weather watch. We're both in North America. Cold, dry, polar air masses form in the northern parts of the continent. Warm, moist, tropical air masses form over water near the southern parts of the continent. Polar air masses usually move toward the south, and tropical air masses usually move toward the north. I'm in a polar air mass now. It's cooler and there's less moisture in the air here than in a tropical air mass, which is what you're in now. But we're going to move you to another place in that air mass.
Why, sir?
So you can be where the action is.
I don't understand, sir.
You will. A WBI van should be pulling up right now.
Yes, it is, sir. They're honking at me.
Well, get in, Wesley. They'll take you to the airport. From there, you'll fly in a WBI plane to a WBI station closer to the cold air mass I'm in.
Sir, are you there, sir?
Yes, Wesley. What is it?
Well, I was just looking at a map I drew. I drew the two air masses you showed me, kind of where I figure they are. If they keep moving like you said they were doing, they're going to bump into each other.
Oh, they've already met, Wesley. Air masses are bumping into each other all the time.
Well, sir, what happens when air masses meet?
Ah, that's what you're going to find out, Wesley.
You mean there'll be weather changes?
That's right, Wesley. And big ones, too. Especially now in early spring when there's a big temperature difference between tropical and polar air masses. But just be patient.
I'll try to be, sir.
Well, are you finally set up, Wesley?
Yes, sir, and waiting patiently.
Very good, Wesley. Anything to report?
Not in the weather, sir, but I've been noticing the weather maps that were in the newspaper the last few days. I saw some things in them that I wanted to ask you about. Take the map for 2 days ago, for instance.
Here's my map for that day. Oh, what was your question?
Well, the map doesn't show the tropical or polar air masses that you showed me, but there's an H.
An H stands for the center of a high-pressure region. That's just another term for one kind of air mass. There's also a high pressure over here. It's the one I'm in now.
A polar mass that moves south.
That's right.
And the one down there must be the air mass over where I am. A tropical air mass that moved northward.
Very good, Wesley. And this curved line between them shows where they're meeting. That's called a front. Now, the prevailing westerlies change the direction of these moving air masses, and winds high above the ground steer them. The winds move the air masses toward the east, and the front is moved toward the east, too. We moved you so you'd be closer to it. It'll be passing over you in a day or two.
What's the L mean?
You mean this? You'll find out soon. Now, did they issue you the training instruments at the WBI office?
Yes, sir.
They'll help you see the sort of changes that take place as the front passes over you. What instruments do you have?
A thermometer to measure temperature.
Barometer?
Yes, that's right, sir. Barometer. They told me it measures air pressure.
Don't forget to set the pointer to mark what the air pressure is now, so you'll be able to notice any change.
I'm doing that, sir.
Good. Now go on.
I have a weather vane. I know what that's for. It tells which direction the wind is blowing, from the southwest now, and how fast. And an umbrella.
That was good thinking, Wesley. Your idea?
No, theirs. But does that mean I can expect rain when the front passes over me?
You'll see, Wesley. It won't be long. Use your eyes and your instruments. Observe the changes and report them to me. Then we'll talk about them.
All right, sir. There's been a small change in the weather, sir.
What sort of change, Wesley?
You know the southwest wind I've been watching? Well, it seems to be blowing harder, and I see dark, puffy clouds in the west.
Those are called cumulonimbus, cumulus rain clouds. Now, look at your barometer. What's happening to the air pressure?
The needle's pointing to a lower number. I'll reset the pointer. Does this mean a lower air pressure?
Yes, that often happens as a front approaches. We say the barometer's falling. What else is happening?
The clouds are closer now. They're very tall clouds, and their bottoms look closer to the ground than they were before. Uh-oh, it's starting to rain.
Umbrella up time.
I guess so, sir. Wow, the wind's getting even stronger. And hey, the barometer's falling. Some more. Air pressure's getting even lower.
I want to show you something on your weather watch. Here's yesterday's weather map. Now, can you guess what the L means?
Well, H stands for high. Does the L stand for low pressure?
Right. Between two air masses, there's a low pressure region. The winds in the two highs move clockwise, the direction the hands of a clock move. But in the low between them, the winds move in the opposite direction, counterclockwise. Air is being drawn from each high into the low, and the warm air and cool air are beginning to mix. The low is called a cyclone, and the highs anticyclones.
Cyclone and anticyclone. Got it, sir.
The front is passing over you now, Wesley. We call this a cold front because the cold air mass is advancing, pushing the warm air mass ahead of it. It'll take several hours for the front to completely pass.
I'll be patient. Sir, I have something to report.
What's that, Wesley?
The wind has changed direction.
And that's what should have happened, Wesley. When part of this weather system was over you, winds were blowing from the southwest. Now the cold air mass is beginning to pass over you, and the winds where you are blowing from the north. And what's happening in the sky?
The sky is clearing, sir. Pretty fast.
And the temperature? Has that changed?
It sure has. It's a lot cooler now.
What about the air pressure?
That seems to be going up again, sir. I guess that must be because the cold air mass has moved over me, and it's a high-pressure region like the warm air mass was.
Quite right, Wesley. And the weather change is over. Here's the weather map that was in today's newspaper. This curved line with the pointed symbols on it represents the cold front, the boundary line between the air masses. It's raining to the east of you now where the front has moved. If the temperature had been below freezing in the polar air mass...
Would there have been snow?
Yes. A cold front like this can produce snow in early spring.
Could you show me that cold front on the map again? Thanks. What's that line attached to it?
This one with the rounded symbols?
Yes. Is that another cold front?
Well, it's a front, but the symbols mean it's a warm front. Here the cold air is retreating, allowing the warm air to mix with it. There's precipitation in this area too, but the weather in places that the warm front passes over will get warmer. And instead of the cumulus rain clouds that the cold front usually produces, a warm front usually produces the flat, straightest rain clouds.
Why are the clouds different?
Well, look at your weather watch, and I'll explain. When air masses meet, a cold air mass usually moves under a warm air mass and begins to lift it off the ground. If the warm, moist air is pushed up rapidly, cumulus rain clouds form, thunderheads. That's typical in a strong cold front where cold air is advancing. At a warm front, where the cold air mass is retreating and the warm air is pushing forward, the warm air in this case is slowly lifted as it gradually slides up the cold air mass. So the clouds tend to form in sheets, straightest clouds. In this way, warm and cold fronts usually follow each other, moving generally eastward across the continent, changing the weather in the places they pass over. What's the weather like now, Wesley?
Clear blue sky, cooler than it was before the front passed. A high pressure region, an air mass, is over me now, an anticyclone. But I'll keep watching the sky and the barometer and have my umbrella ready because I know the weather's going to change. But from now on, I'll know why.